Alright, so that's some of the post effects we can do. Now let's move on to some other post effects. Uh, it's possible to create some blur by using the same technique that we're using over here, but a bit different. Right now, as you can see, when we scale this up, we're sort of blurring the image while splitting the channels. But instead of just splitting the channels, we can simply keep everything to RGB. And of course, we're not gonna bend all this, because then you get a 9 channel value, if it's even possible. But now that we have this, how do I do it again? I think I'm simply lerping between them. So I will lerp this with a value of 0.5. It's not the best practice. I think there's a better way to do it. And then I will lerp these ones together with another value of 0.5. And now you will get, there's one image that goes to the left, another image that goes to the right, and one that stays in the center. Well, I say left, but left, bottom left, and then top right. Or no, it was actually top left and bottom right, and one stays at the center. And we need more samples for this. So this is the one that stays in place. We need two more samples, one that goes top right and bottom left. And you're gonna understand what we're doing with all this soon enough. So we're just gonna copy this and paste it. So up here we were going 0.1, 0.1, minus 0.1, minus 0.1. So we just need the other values that come with this. So we're gonna need a point 0.01 actually, sorry, and then minus 0.01. So now this one is being displaced in one of the other directions. And then again, there might be other ways to do some blur that are cheaper. I don't know, I'm just showing you the way I do it. And this one is going to be minus 0.01 and 0.01. So we have the RGB over there. We need more lerps again. You know what, let's just do it that way. And we don't really need this one anymore, not for now, because we're just blurring everything. We don't really need the initial position. So now we have samples that are coming from all directions. Let's simply plug this here and let's save. Did it compile? I think this number is too low right now, but if I yes, so if I raise the value, the displacement becomes bigger, and you can get this blur effect. Now if I put this value too far, like you can see the image splitting, and of course it becomes not so much as a blur, but more like just some sort of doubling effect, or in our case, it's a quadrupling the image. But as long as you keep the value low enough, look at those spots over there, and if we just scale it down close enough, now it really looks like everything is just blurred. And of course, there are ways to have more control over all of this. We have our unblurred image over here, the one that is not displaced. So something that we could do, if we import a texture, let's go just going straight in the assets of a different project. But yeah, let's get this gradient over here. Let's plug it there. And we are going to use this texture. We're gonna need screen position again for the UVs. And yeah, you can actually use a texture as the as everything you see. So if I just plug this gradient over there and save, our entire screen is simply going to show this gradient. Yeah, just like this. So now that you know that we can actually do something like that, we can actually use this as a mask to isolate one post-process from another. In our case, this is our scene which is untouched, and we have the blur over there. We can get another lerp like this, and we can use the texture over there as the alpha for this lerp. So everything that is in white is going to show this part over here, and as it goes towards black in the texture, it's going to show what we have there. So our blur is only going to be on the edges of the screen and not at the center of what we see. See how it's clean over here in the center? But if I move, it becomes blurry. So that's one of the things. So this method over here can be combined with any other effect, like the desaturation that we had earlier, or the RGB abrasion that we had. You can use this type of thing to isolate the post effects. So let me think of another post effects that we could do. Um, There's one that I really like. It's the pixelization, you know. So let's just delete all this. We've been through it. Or you know what? I'm just gonna keep it in case I would like to do something else with it later. So I'm just gonna move this back here. Gonna move this up. I actually don't really need this anymore. If need be, I can just redo it. Yeah, let's just do this. All right. So we have the UVs over here. Something that is nice is to pixelize the UVs. And the way to pixelize the UVs is instead of having such a smooth gradient that is like this, we want to everything to be sort of like pixels. And the way to do this is it's really simple. If I just frac everything, no, actually not frac. Frac is not what I want to show you. If I floor everything, right now the screen goes from 0 to 1. So if I floor, everything that is underneath 1 is just worth 0. And you'll see where I'm going with this. So I'm just gonna floor this. Everything is going to be black, obviously. And if I were to multiply this by 2, and then I floor it, then we're gonna have half the screen, or 1/4 actually, be black, and the rest will be white. And then a combination of both. So you get this. So it's actually, the values are actually going from 0 to 1 and from 1 to 2. But since it's floor, it's 0, 1. And then same thing here, 0, 1. And then over here we have 1 in the red channel and 1 in the green channel, which gives us a yellow. So what we can do with this afterwards is we multiply by 2, we floor, and then we divide it again by the same number we have there, which is a 2. Then we plug it here and we save. And now instead of going from 0 to 1, it's going from 0 to 0.5 because it's being divided by 2. Now, where I'm going with this is if I put a scalar parameter over here, because you always want to divide by the same number that you multiplied before the floor. If we put something like 64, now, well, I hope the video quality is good enough. You know what? I'm gonna reduce it. I'm gonna reduce this number to 32, just to make sure that it's visible. Now, as you can see, you have all of these squares over here for the UVs. So you're going from 0 to a fraction of 64, and then the second fraction, not 64 but 32. But basically, we just sort of stepped our UVs 32 times instead of being something very smooth. So what happens when you use this as the UVs now for our post effects? Each of these cells is going to be a single color. There you go. So if we go here, we can play with this value and change the size of the pixels. See? I really like this effect. And of course, those pixels are not actual square pixels because the screen ratio was not accounted for inside of the effect, since it's larger than it is it is wider than it is high. We just need to use the screen resolution and do some sort of math in order to get a ratio. So the way I do it, I thought normalize would work earlier, but I don't think it does. So I can simply break out float 2. So this node over here, because this has like the horizontal value and the vertical value. So this node breaks each of those into its different vectors. So we have horizontal and vertical. We need to get the max out of them. And then we need to divide each of those values individually by the max. And then we append. So this, what's coming out of here is an actual ratio of what the pixel should be. I hope I'm doing it right. I'm just doing it from my memory, but it's not actually tested. So then I can simply multiply the number I have here by this ratio. I might have to inverse it afterwards, I'm not sure anymore. And if I save, they're either gonna get longer or they're gonna get square. They got square. Yeah. So yeah, this little branch over here, I'm just gonna leave it here so you can press pause in case you want to redo it on your hand. So I've got this, which leads to this, which goes there. And if I scale it, if I drop down, then I can really change the pixel value, the size of the pixels. So like I said, we can use that gradient for lerping. So let's try it. I'm not sure if it's gonna give anything good, but you know, just for fun. Let's lerp. Let's get the screen position as the UVs for this thing over here, and then we plug red channel in the alpha, this over there, and this over here, and that's it. So it's going to transition from being pixelated but unblurred to being blurred. I don't know if I don't know if any game has a need for this type of effect, but now you know how to make this effect. All right, so um, let's move on to something actually simpler. So I'm just gonna delete all that because I don't need it. I know how to redo it. Easy peasy. Let's just plug this here. Um, well, we have that gradient. You know what? I deleted it. Let's get it back. So you're playing this game, a gun shooting game where when you get hurt, the screen becomes red. So something very, very simple. You lerp again. Um, you get, let's get a color. Gonna put it red, obviously, because kind of game doesn't have blood. And then we plug this here. And now we have this, which is pretty bright, you know. Maybe we can change the color a bit. Blood would be a bit darker, maybe something like this. Yeah. And maybe we can power this. Multiplying it by itself is the equivalent of saying power, the power of 2. So it's going to push the redness towards the edge. Oh, actually the opposite. I need to square. I want to square root it. Yeah, yeah. So we have this effect. Obviously, fading to just a simple color is kind of lazy and boring. So something that we could do to make the effect more interesting is we get this entire thing again, and let's get our desaturation again. We desaturate this thing to 1, and then we lerp the result using this. So the desaturated result is going to lerp between black and red instead of between black and white. So now let's save. So now instead of fading towards just a single color, we are keeping information of like the black and white, but instead of going from black to white, it goes from black to red, and you get this effect, which is a bit more interesting, I think. And maybe it gets a bit too dark, so maybe we can simply tweak that color to compensate for this. So if we go here and we make it brighter, yeah, I like this. And just a simple fade like this is kind of boring too, so we might as well use a noise in it. So let's import another texture. My favorite noise is there. Can always count on it. Looks so cool. Let me just save. So let's drag this here, and let's mess around. Let's get a screen resolution, not screen resolution, but screen position. so that we can get the UVs. So we have this, we have the desaturation over there. Maybe what we can do is we multiply, we multiply this together, and it should give a sort of pattern now inside of the blood. Yeah, see this type of effect over here? It's a bit too dark. Maybe, yeah, it's being multiplied. What if yeah, right now I'm just messing around, just figuring out like which math fits better. It's not anything to know by heart. You just have to know like what math calculation has what effect, you know. So I'm going to instead subtract this, and I need to saturate it so that nothing goes below 0. So if you subtract black, you get, you're not really subtracting anything because black is 0. So what I'm doing, since there's a lot of black in that texture, using a subtract like this is actually making me not lose as much details. So now as you can see, there's a pattern over here. You can see the noise inside of the effect. Something that we can also do, is to use UV distortion with a texture, and for this we simply need a normal map. So let's find one. Where do we have a normal map? Fireworks? No, there were no normal maps there. Meteor, yeah, the meteor had one. Texture, did it have one? Please, it doesn't have one. All right, just bear with me. This is year 2, class 7. Nothing here. Class 8. Was that the Kamehameha? How come I don't have a single normal map texture laying around? Let's go here. You know what? I'm gonna stop the video here and find a normal map.